Value decreases with increase in pressure at constant temperature. When? When PV value decreases with increase in pressure. Here if you draw a graph, P versus PV. Here PV I have taken product of pressure and volume, and pressure I have taken on x-axis. Now we know that pressure if you increase, you take a box, pressure if you increase, molecules comes very near to each other. If I am going right hand side, if I am increasing, pressure and volume product if you take, pressure you are increasing. So apart from the pressure, we know that according to Boyle's law, pressure is inversely proportional to volume. If 2 times pressure if you increase, 2 times volume will decrease. If you increase the pressure 2 times, volume will decrease 2 times. Means for ideal gases, there are no interactions. Okay, attractions are equal to repulsions. That time only this is possible. For example, if attractions are more, now if you are applying more pressure, atoms are coming together, more attractions are there, means what will happen? They attract each other strongly and the volume reduces further than what we expect. So that's what for ideal gases if you take. Okay, in Boyle's law also we have seen this graph, pressure versus PV if you take it, graph will be a like straight line for ideal gas. Okay, but if you take some real gas, no such ideal gas exists in reality. So all gases are real gases. So easily if you P versus PV graph if you take, real gases won't get straight line. So there is a significant deviation from ideal behavior. There are 2 types of curves are there, positive type and negative type curves. Okay, so first curve if you take, for example, like hydrogen and helium, there are no attractions between their atoms. So if you increase the pressure, PV value also increases. So there are some repulsions are there compared to attractions. So what will happen? The graph you will get like this. For hydrogen and helium, we get a positive slope graphs. So this is also like PV by RT. You can take either PV or PV by RT, means that is equal to compressibility factor. Why? Because PV is directly proportional to Z, or Z is equal to directly proportional to PV. Either Z or PV by RT you can take it. Then ideal gas will be always straight line. For hydrogen and helium if you take, they will be having more repulsions. So you will get positive slope. If you take like carbon dioxide or ammonia, like ammonia and carbon dioxide, we will get negative slope first. Negative slope means Z value is less than 1. PV by RT. More attractions are there means they attract each other and they liquefy. This only we call liquefaction of gases based on compressibility factor. So what will happen? First there is a negative deviation from ideal behavior, then PV value decreases with increase in pressure and reaches to minimum value. Here this reaches to minimum value, and finally if you increase further pressure, then it increases further. First it decreases, PV value decreases some extent. Why? Because attractive forces are there. So whenever attractive forces between the molecules are predominant, PV values get decreases.